Hi, welcome back and to this our first lecture on PLSQL functions. Should be great fun. We are going to take a look at a function which calculates the relative strength of a user supplied password. Now, when I started this lecture, I of course had no idea what a good versus a bad password strength algorithm looked like, so I did what everybody else would do. I went out to Google and started asking questions. Well, Google did what it always does, and it returned about 2 million options. Here you go, Rick. Take your pick. What did I learn? Lesson number one, that about 99.9% of the code that's out there and is free for a reason. It's junk. It's not worth anything. Actually, at zero, it's overpriced. Just horrific attempts at a password strength calculation routines. Ultimately, I did fall on one by passwordmeter.com. We'll take a look at it. It's a pretty good algorithm, although I do believe even this one has some bugs in it, and we'll take a look at those and try to correct them as well. I then followed their links to look at the source code, which of course again was not there. People, stop abusing the internet. It is not a tool by which you rip other people off. It is a tool by which we share information. Please, please, please. In any case, enough lecturing. So my second lesson was on reverse engineering and online form. It's delicate work, it's difficult, and you need to really test that software at its limits and assume that it's wrong and then try to figure it out from there. Just like testing your own software. All right, given those caveats, let's jump into lecture number 11, script.txt, and take a look at the calc password strength function. Should be great fun. We'll see on the inside.
Okay, I'm going to assume you understand our function signature. Function signatures differ from procedure signatures in that they return a value, but otherwise everything remains the same. In our case, our little function here is going to return an integer in the range of 0 to 100, where a value of 100 infers the strongest possible password. Functions do differ, however, from procedures in that they may be used in SQL select statements and as right-hand operand in assignment statements. If you're going to use a user-defined function in an SQL select statement, then it must return an Oracle primitive. Otherwise, functions used as the right-hand operand in a PLSQL assignment statement may be user-defined to any degree of complexity. Okay, enough of that. Let's move down our code to the line which reads type myArray is table of car1 indexed by binary integer. Do you recognize this syntax from our earlier discussion of collections? Sure. That guy's an associative table of car1 variables indexed on a 1-based integer, aka an array. Check out those next couple of lines of code. We now use that user-defined structure to define 3 arrays. One will hold a list of uppercase letters, a second will hold a list of lowercase letters, and a third will hold a list of keyboard symbols. Note, we use this implementation because later on down this code, we're going to look for sequences in the user-defined password. And according to the people at passwordmeter.com, a sequence is defined as 3 or more letters, symbols, or numbers as arranged on the keyboard, not in their ASCII sequence. Yes, that's right. And if you think about it, it makes some sense. Net, uppercase QWE is a sequence. Lowercase ABC's not. Kind of counterintuitive, but again, if you think about it with respect to passwords, you don't want people being able to use those quick finger sequences. Okay, now I want you to jump down to the first line of code in the body of our calc password strength function. Looks like we're calling a procedure named populate arrays. Okay, but where is that guy? We've not previously defined that guy anywhere in our previous lessons. Easy. It's up in the declaration section of this function, aka it's an embedded function. Let's check it out. There it is up in our declaration section, and it looks like any other procedure signature except we don't include the create or replace keywords. Remember though, you still got to qualify this end statement with the procedure name, in our case, populate arrays. One more thing I want to mention here. Please notice that our array variables are within the scope of both the calc password strength function and the embedded populate arrays procedure. All variables declared within the primary subroutine are also available to the embedded subroutines. What would happen if you declared additional variables within the embedded subroutine? That's right, they would not be available to the parent. Check this code out. The available to both variable is available for use by either the parent routine or the embedded routine. Compare that to the local variable declared within the embedded routine. That variable is not available to the parent routine. All right, now we're back in the body of our parent routine, and it's time to start looking at the logic of the calc password strength function. As mentioned above, we begin by populating our symbol, lower, and uppercase arrays, and then we realize our first algorithm criterion. More specifically, the algorithm states that any password less than 8 characters in length is automatically rejected. Now, those of you who've studied the online solution will know that the online solution still gives a strength value for passwords less than 8 characters in length. Personally, I think it's probably an undocumented feature, so we're going to go ahead and return our default password strength value of 0 for a password which is less than 8 characters in length. Oh, and remember, undocumented features, just another word for bug. All right, now we move on to our next algorithm criterion. More specifically, the folks at passwordmeter.com next said that a valid password must minimally contain 3 of the 4 following: a lowercase letter, an uppercase letter, a keyboard symbol, and a number. Sounds good. Let's write the code. We begin by setting up an outer for loop, which is going to walk the length of our user supplied password. I chose an I as the loop control variable for that outer loop. Next, we set up an inner loop to scan through our arrays. First, a lowercase array where I again chose a J as my LCV. Please note the use of the found L-case variable, which assumes a 0 for false and a 1 for true in a Boolean-like fashion. We're going to use those guys to add them up later. And then we'll also keep a counter for use later down the code. We're doing the same sort of thing for the uppercase letters and the symbols. Please note we didn't need an array for the numbers as they were already in sequence in their ASCII form. We concluded this part of the password strength test by simply summing the 4 Boolean 0, 1 variables and then testing that value against the 3 value minimum. Again, unlike the online version, but again consistent with their documentation, we will return a 0 value password strength variable if the criterion is not met. Okay, now we're going to move on to the positive attributes beyond those minimally required. First off, we're going to grant 2 points for each of the 5 minimal criteria met. Code here is pretty straightforward. We know password length is greater than 8 if we made it this far in the code, so we simply add 1 to our previous Boolean variables and then multiply the value by 2. Next positive attribute is even more straightforward. Simply multiply the length of a user supplied password by 4. All right, moving on to award points based on the number of upper and lowercase letters. In particular, we take the overall length of the password and then subtract the number of uppercase, multiply by 2. Same thing with the lowercase. The algorithm is equally straightforward with respect to numbers and symbols. Straight arithmetic here, you guys can catch that real easy. The next positive attribute rewarded by the algorithm is middle numbers or symbols. Now, the best I could tell, a middle number or symbol was one that had both prior and subsequent characters. For example, in this password, the $sign, underscore, and both zeros would be considered middle symbols or numbers. That trailing percent sign is not a middle character. Interestingly enough, the online solution actually calculates this password incorrectly because for some reason it does not include the underscore in its symbols list. It does include the dash. Oops, probably a bug. Let's check out our code. As you would have guessed, we begin by setting up a loop to walk the length of our user-supplied password, but this time we begin with characters 2 and end with 1 prior to the end, as neither of those can be middle characters. We then set 2 booleans corresponding to prior and subsequent letters. Check whether the current password is a number, and if it is, set up an internal for loop to check the prior and subsequent letters. The bottom half of this section does the exact same thing, but also requires a loop to check whether the current password character is a symbol. Note the check for the ILCV being a middle number. You don't want to undo a positive finding by checking for a middle symbol if you've already determined it was a middle number. Finally, we conclude the section with some simple arithmetic wherein we award 2 points for each middle number or symbol. Cool beans. Okay, now we move on to the contraindicated password attributes, i.e. those things which are going to remove strength points. The first two shown on the online form are negative points for all letters and or numbers. Well, gang, this is what I refer to as an idiot check. If they had properly enforced their 3 out of 4 rule criterion up above, then these conditions simply wouldn't have been needed. That is, they are 100% redundant with that minimum criterion up above, aka an idiot check. Can you write the exact same piece of code twice without putting a bug in one of them? Well, in the case of our online friends, the unfortunate answer appears to be no. Once I wrote this code and saw what they were actually doing, I simply commented it out of mind. Yes, that's true. I passed the idiot check. The next criterion for the online form is the existence of repeating characters case insensitive. Again, in my opinion, this is our online friend's biggest undocumented feature. Here's a screenshot of a password with 3 occurrences of repeating case insensitive repeaters. The online code caught exactly 0 of them. Good news, our version of the code catches all 3. Did you notice how we took advantage of the ASCII sequence of the upper and lowercase letters? Yes, ASCII capital A minus ASCII capital letter lowercase a is 32. Throw in that absolute function on this difference and we handle repeaters going either way, lower to upper, upper to lower. Oh, by the way, the reason we multiplied the repeater count by 3 was because the next section of the online version is just simply nothing more than another idiot check. If they had written the case insensitive portion correctly, then these wouldn't have been required, aka idiot check. Our code gets all 3 of them in one pass. Net online code is often free because it's exactly what it's worth. Nothing. Hey, remember, this was one of the good ones. Our final negative factor is 3 consecutive numbers, letters, or symbols. Nested loops, where we use the corresponding loop control variables to walk the user password as well as the corresponding arrays, gets the job done very nicely. Check this out, guys. That code is really quite elegant, very common usage, and so darn clean all at the same time. Hope you enjoyed it. Please study that script offline because I know it's a little dense, but very important because it's something you're going to use every day. Oh, final note. Remember to return that final password strength variable or your compiler will ultimately fail. Cool. See you on the outside.
All right, welcome back. I hope that was fun for you. I know that code's a little dense, so take your time, work your way through it offline, review this lecture as many times you need, but please make sure you get on SQL Developer, get that loaded up, and practice. You know, if you have to, what I do lots of times is just rewrite the code myself. That makes me think my way through it. And I was, at least for me, helped a lot with respect to learning the new techniques. All right, so what did we learn in this lecture? Well, first and foremost, that most free online software is in fact overpriced. It's just junk. I searched up and down for this one to determine that it was pretty good, but ultimately I think we all agree that this one had some online bugs as well. I mean, who puts this kind of stuff out there? I mean, it's embarrassing in any case. That was lesson number one. Lesson number two, we learned how functions differ from procedures, and quite frankly, not very much. They simply return a value, whereas procedures have only input and output values. Fun thing about functions is they can be used in SQL select statements and as the right operand in PLSQL assignment statements. Now, please remember that if you're going to use it in a select, that needs to return a primitive, whereas in an assignment statement, it can be easier defined to any degree of complexity. Second, we learned about for loops and the use of their loop control variable as an element in the substring function. A really powerful method for walking the length of a string, looking for series, looking for special characters. I mean, it's real common stuff. Finally, we learned about embedded subroutines as well as managing the scope of variables between the parent and the embedded. Just remember that, in fact, the scope of other variables declared within the parent declaration section are available with respect to scope by the embedded as well as the parent, whereas anything declared exclusively within the embedded is available only to the embedded. Word of advice there, and I've seen it abused in the past. Please don't use the same variable name in those embedded ones. It makes people crazy who are trying to debug your code later on down the line. All right, that pretty much handles it for this, our first lecture on functions. In our next lecture, we are going to tackle a function which predicts the best next play in an NFL football game based on current conditions and past history of the performance of the teams. Should be cool. I'm looking forward to it. All right, you know the gig. In the interim, you guys go out there and you have some fun, but please learn something every day. It's the good stuff and it's important.